Now, in this video, we are going to take up one more problem on the steel bar. So here, a bar of 600 mm long is having a square section of size 50 mm by 50 mm. If the bar is subjected to an axial load of 120 kN and lateral compression load of 600 kN on faces of sizes 50 mm by 600 mm, find the changes in size and volume. Take E equals 2 into 10 to the power of 5 Newton per mm square and the Poisson's ratio as 0.3. So here you have 120 kilonewton acting along the x-axis and 600 kilonewton on P2, which is compressive, which is on the faces of 50 mm by 600, and also on 600 kilonewton compressive on 600 by 50. So Young's modulus is given and also the Poisson's ratio is given. Now to find out that, so what is the stress in the direction of xs? That is load in the direction of xx, that is P1 divided by area of cross section perpendicular to the direction of P1. So what is the load? We are talking about the load as 120 kilonewton acting along the direction of x, perpendicular to the area of perpendicular to the direction of load, which is the area of cross section is 50 by 50. So that is what we want to take here. So here sigma x will be 120 into 10 to the power of 3 by 50 into 50. So on simplification, you will going to get this value as 48 Newton per mm square, which is tensile. Then again stress in the direction of yy will be equal to sigma y is load in the direction of yy, which is P2 divided by area of cross section perpendicular to the direction of P2. So what is the load in the direction of yy, which is P2, which will be 600 kilonewton, that is 600 into 10 to the power of 3 or 6 into 10 to the power of 5, perpendicular to the direction of P2, which will be 600 into 50. So on simplification, you are going to get it as 20 Newton per mm square, which is of compressive stress. Similarly, what is the stress in the direction of zz, which is sigma z, which will be load in the, it is the ratio of load in the direction of zz, which is P3, and divided by area of cross section perpendicular to the direction of P3. So what is that? Sigma z will be equal to, which is again 600 into 10 to the power of 3 divided by 600 into 50. So on simplification, you will going to get it as 20 Newton per mm square. Since it is the compressive load is applied, so naturally you will going to stress developed is compressive stress. What is the strain in the direction of xx, which epsilon x will be equal to sigma x by E minus sigma y by m into E minus sigma z into m into E. But actually the load, the tensile is positive, that x is positive because it is a tensile load. Sigma y is negative because it is the compressive. Sigma z is also negative, it is compressive. So sigma y value is minus of minus, so naturally it becomes plus, and sigma z minus of minus sigma z, so it will be positive. So therefore you will going to get it as sigma x by E plus 1 by m into E. By taking the common factor of Poisson's ratio and Young's modulus, you are going to get sigma y plus sigma z. Since the load, in other words, the load acting along the direction of x, which will going to be increase in length, so naturally it is sigma x, and the lateral dimension, which is sigma y and sigma z, will going to be negative. So therefore, so the positive sign due to the compressive stress of sigma y and sigma z. So substitute the values of sigma x, sigma y and sigma z, and also the Young's modulus and Poisson's ratio, which is 1 by m. So which is 48 by 2 into 10 to the power of 5 plus, then 0.3 by 2 into 10 to the power of 5 into 20 plus 20. So which will be equal to 3 into 10 to the power of minus 4, which is the epsilon x. Similarly, you want, what is epsilon x? Epsilon x is also equal to delta L by L. We know the longitudinal strain and also the change, the length. So therefore, the 3 into, substitute the value of epsilon x and L. 3 into 10 to the power of minus 4 equals delta L by 600. So on simplification, delta L will be equal to 0.18 mm. Similarly, therefore, the change in length delta L will be equal to 0.18 mm. Since it is the positive value or it is the tensile value, so therefore you will going to get the increase in length. So now when you are taking the strain in the direction of yy, so what is the strain in the direction of yy, which is epsilon y will be equal to minus sigma y E minus 1 by m into E into sigma x minus sigma z. So here Actually, the equation says sigma y by E minus sigma z by m into E minus sigma x by m into E. Since the load applied in the y direction is compressive, therefore you are getting negative. So that is the reason why you are getting negative here. But sigma x is again, it is tensile, but the problem says it is in the negative direction. So the formula says it is the negative. For y, it becomes lateral will be x and z. So therefore, you are getting negative here. So substituting the value of sigma y, sigma z and sigma x and E and 1 by m. So what is that? Sigma y will be minus 20 by 2 into 10 to the power of 5 minus 0.3 divided by 2 into 10 to the power of 5 into 48 minus 20. On simplification, you will going to get it as minus 1.42 into 10 to the power of minus 4. Similarly, what is epsilon y? Epsilon y is equal to delta b by b. You know the value of epsilon y, we know the value of b, therefore change in width can be calculated, which is delta b. So that is, substitute the value of epsilon y, which is minus 1.42 into 10 to the power of minus 4 equals delta b by b is 50. So on calculation, change in width will be minus 7.1 into 10 to the power of minus 3 mm. So since it is negative sign, it is the decrease. In other words, the load applied is the compressive load. So naturally, there will be the decrease in width. Now, when you are considering the strain in the direction of ZZ, which is epsilon Z, will be equal to minus sigma x by m into E, then minus of minus sigma y by m into E, then plus of minus sigma z by E. Why negative here? Because it is incompressive in nature, compressive stress. Then minus sigma x by m into E plus sigma y by m into E minus sigma z by E. So that is equal to sigma z by E minus sigma y by m into E into minus 1 by m into E into sigma x by sigma z. Or you can take it as, so here minus, substituting these values, minus 20 by 2 into 10 to the power of 5, that is sigma z value, minus 0.3 into 2 into 10 to the power of 5 into 48 minus 20. So that will be equal to, on simplification, you will going to get it as minus 1.42 into 10 to the power of minus 4. Once you get this value, so also epsilon z will be equal to delta z by z or delta d by d. So epsilon z, you know the value of epsilon z, substitute that value into 10 to the power of minus 4, 1.42 into 10 to the power of minus 4, which is equal to delta d by 50. On simplification, change in depth delta d will be equal to minus 7.1 into 10 to the power of minus 3 mm, which is again, it is decrease in width. Now once you get this, now we want to find out the volumetric strain. What is epsilon v, which is epsilon x plus epsilon y plus epsilon z. You know that epsilon x is 3 into 10 to the power of minus 4. Epsilon y is minus 1.42 into 10 to the power of minus 4. Epsilon z is also minus 1.42 into 10 to the power of minus 4. On simplification, you will going to get it as 0.16 into 10 to the power of minus 3. Also, what is epsilon v, which is delta v by v. So, you know delta epsilon v is 0.16 into 10 to the power of minus 4, which is equal to delta v by 600 into 50 into 50. So, on simplification, change in volume, delta v will be equal to 24 mm cube. Since it is a positive value, therefore the final will be, it is the increase in volume. So this is how you will be able to find the solution for this particular problem. Thank you.